good morning, good evening, everybody, wherever you are in the world. Welcome to another edition of CGS Live VFX Special. I hope everybody had a good weekend or is having a good weekend. It's always hard trying to remember what day it is all around the world. Today I'm just going to work on finishing off what I was doing. Hey Hardik, how's it going? Hey Audrey, welcome, thanks for joining me. Today I'm going to just work on finishing off the tornado, and then I think I'll maybe talk about some other things that we could work on as well. But premiere of Sharknado. No, that's next week. Hey Matea. Hardik, thank you. I'm doing well. Thank you. How are you? Hey Hamid, how's it going? Nice to see you guys here. Yeah, so today I'm just gonna, let me jump into Houdini, and I just did a little flipbook of what I ended up getting last week. I don't know how well these things play back for you guys on the stream, but you can see I did end up tweaking this after the stream just to get the behavior that I was after, and I managed to get the boards to come off. And I think there was an issue that I hadn't really seen when I was trying to do it, and it was the reason I couldn't get the boards to pull off last time was because in here, in this subsolver, what I was trying to do was use the name attribute as a grouping function, which works fine usually, but the issue was that I was trying to run it over primitives, which is what the constraints are, but the name attribute actually is not a primitive attribute. So when this is set to run over primitives, these actually weren't working. So I had to promote the name from point to primitive. So now, as soon as I did that, I got that behavior that I was after, the sort of tearing off of the weatherboards. So that was the main thing that was sort of stopping it from working. I tweaked a few other things just to get better behavior. I've got those roof pieces kind of hanging on a bit more now as well. I've got this other angle here, which is kind of more inside the tornado. I don't know what's going on here. There's something weird going on with this piece, but you can see they sort of lift up and then, they flap around a little bit and then kind of fly off. So yeah, overall, I'm mostly happy with that kind of simulation. There's a few little errors and things that need to be fixed up. Obviously, you can see at this camera angle or this distance from the camera, there are certain things that don't hold up, like these beams that just kind of separate from each other. They sort of don't, they don't work well at this distance from camera. But if we look at the other camera angle, which is our main camera, it's kind of fine, that sort of works okay. I also had to move the tornado, so I transformed it here. If you have a look at our original position, I just moved it over a little bit. So I just basically tried to position it in a way that it wouldn't completely run over everything and just hide the house completely. So I just shifted it a little bit so it would just kind of skim the house and not completely go over the top of it, because we lose all that nice simulation. Yeah, it looks pretty cool, Audrey. Tornado Man. Hey Robert, how's it going? Good morning. So I'm pretty happy with how this is going. I think ultimately I probably would go back to the tornado and do some more work on that. But the last thing that I kind of want to add to this house simulation is just like dust and some little kind of additional elements that will make this just feel a bit more realistic and a lot more detailed. So let's have a look. I just wrote out my simulation to disk here. Here's my RBDs. So they're packed at this point, yes. I'll just move this over here. So you can see the packed fragments, 2000 pieces, so not loads, but quite a lot. And if you remember from last week, what we were doing was, or what I was doing, was taking my roof pieces and kind of eating little holes out of them via a noise map, and then point deforming them back on to their simulated piece. So if you didn't see that, you know, you can go back and have a look at that. But you can see there's something weird happening with this one. I don't know what's going on with this particular piece, but it's kind of it's freaking out a little bit. Let's have a look. So there's our sim. That's what it should look like. But for some reason, some wacky thing that I'm doing here is shifting these a little bit, which is odd. So we've got that. Maybe that's... Oh no. I think here, my time shift. What I did actually, that's why. So what I did here was I changed the start frame. It was 250 previously, but now it's 150, and that's why there's an offset. So let me just make that match, 150, and then that should line up. There we go. That looks better. And they should all deform along with their respective pieces. Merge that back together with the rest of the house. Color, time shift. Alright, cool. So, yeah, what I want to get happening is before this tornado kind of rips this house apart, I want to get some dust flying off. And then finally, when it does tear it apart more, I want some more debris and dust to fly off it as well. So let's have a look at what we can do there. And I think I've probably shown, you know, some of these techniques in the past using, we could use a debris source. So I really like using the debris source with RBDs. We need to unpack it first and make sure that we've got velocity. We don't, so let's transfer it. So we've got all my mislabeled markers. Let's label these correctly so I know what I've got here. Distance, so we don't need that one. Marker 3, what's this? This is the name. These are all handy, but it's kind of makes it difficult if you don't label them. You can't really see what you're working with. Curve U, we probably don't need to worry about that one anymore. We used that way back at the start, and there's our velocity there. So you can see that there on the roof. You know, we're getting some motion. There's a little bit of a spike right at the start. You can see that would be something that I would want to fix. There's a little pop right at the start there when the sim starts. A little pop up and then settle. It's probably caused by interaction between the roof pieces and the kind of beams underneath. It's just a little collision probably that's happening there, and then they settle back down. So what I might do is like actually take the sim from a few frames after the start, maybe, you know, there, and just hold it before that so that we eliminate that pop. Might be a good way to kind of get rid of it. So let's see, plug that into a debris source, and we'll set the rest frame, which is the start frame of this kind of solve, to be the same as our start frame of our sim. And then we should see points get created when the pieces are disconnected from each other. So it's a really easy way of just detecting when two RBD pieces separate, and it gives you these points. So if I was to run that into, say, a pop sim, pop network, and I'll make that start at the same frame as well. So 150. Hit play. We need to change our source type to points, and that's going to use a birth rate to emit those. So if we go back to the start, we should see now we get points kind of flying out based on the velocity that they had inherited from that piece. So you'll see there's a ton that just kind of rise upwards, but some get kind of flung elsewhere. And, you know, that's not exactly what I want, but just to demonstrate kind of what this is going to give me, it gives me a whole bunch of points, which is good. Now, for like a dust source or something, you probably only want to give those a very small life. So let's go like, hey Rizwan, how's it going? You're trying to assemble scene files in what? So you can see when I set the life expectancy really low, they just kind of flash on for a little bit. The blue ones are the source points. If I turn that guide off, then you can kind of see those just flash on. And that's kind of going to be a little bit of a better source maybe for a dust simulation perhaps. But let's see what else we could do. So instead of maybe the debris source, another thing that we could do here, Lightwave. Well, I can't help you with that. Sorry, I've never used Lightwave. What are you trying to do exactly? So one thing that I could try and do here is maybe attach points to this simulation geometry. So maybe I'll scatter a whole bunch of points. Maybe, yeah, that'll do for starters. What I'll actually do is freeze this, I think. Scatter points, and then I'm going to turn on output attributes source prim and source prim UV. I was going to do a point deform, but there's a better way to do it when you have such, straightforward sort of thing like this where you're just scattering on the geometry and then you want to transform those points by the original animation. And because these aren't being deleted or, it's all very straightforward. So we can use an attribute interpolate node. And that, you can see here, it takes those attributes that we just enabled on the scatter. And hopefully you can see that those points just follow along now. It's very quick. So we've got these points attached to our base geometry now, which is cool. And we can up the amount like that. And now what we could do, we've got velocity on here, although it's frozen at the moment. Let's see, point attribute star. So I think if we, oh no, we are actually getting our velocities. They must be coming through from here, which is good. So it's copying those off of the source as well, because here we don't actually have any. So it must be copying those with that point attribute star there. So we could actually just specify which one we wanted to copy. But that's great, because now we've got velocity. And what we could do with that velocity is, in a wrangle maybe, we could take the length. So we could say if at length, well, not an attribute, if length v at v is less than, let's just say 1 for starters, remove point. 0 for the first input at pt num, so we remove any point that has a speed less than 1, and then just close that off. And you can see they all go away, except for these ones that are actually moving faster than 1. So the length basically kind of calculates the speed of a particle, or how big that velocity vector is. So the larger it is, the faster that particle will move. So it's going to measure the kind of speed, and then we're just removing it if the speed is less than 1. So you can see now we only get particles when they start moving, which is cool. And as they really start moving, you can see right at the end here, we get a lot of points. So what could we do with that? We could also say greater than. So we could say if length is less than 1 and greater than 5, let's say. Oh, actually, or. Let's do or. Or is the pipes. There we go. So that should also remove the really fast ones. We could even take that down. So we could do less than 1 and greater than 2. Or we could do, just a very small range so that it samples it right at 1. And then if it goes slightly over 1, then it gets removed. And if it goes below 1, then it gets removed. And then we just end up with a little kind of what? Sorry, Hardik, I don't understand. As PT I assume you mean PT num. What is for fast? Yeah, I'm not. Can you rephrase that question? I don't really understand. Sorry. So what we end up with is this kind of, this real flashing sort of thing. But that's good for an emission. So what we'll end up with is, if we run that through the through the PopNet, let me just reset that. Play. Oh, let me up the life. 0.25, let's say. Oh, I'm not viewing the sim, that would help. There we go. So you can see now I'm getting a similar thing where I'm getting points emitted, but now they're not based on separation, they're just based on speed. So when things start moving instead of when things separate from another thing. So that might be useful as well. Now let's increase this a little bit. Let's go 0.5. Let's turn a node on and off. Alright, so let's just merge this with our original simulation and just see kind of what it looks like, whether it relates. Oh, do you mean PT num? It would be, if I write it in the chat, PT num. So PT num is the point number. Basically, it's the attribute, and you can't see it on here. It doesn't show up as an attribute, but it's like a kind of global attribute that exists, and it just describes the point number. So if you have a look on the geometry spreadsheet, here we've got all these points. So on our scene view, here's all our points, right? The geometry spreadsheet shows us all the information that exists on those points. And you can see on the far left here, we've got these numbers. And this is the point number. So you can see, if I middle click on the geometry, I can see I've got 100,000 points. And I can see down here, I've got 99999. So 99,999 point numbers. But there are 100,000 points because it starts at 0. So the final number is not 100,000, it's one less. So that is the number of each one of those points. And if I come to the scene view and turn on my point number display, I can see that each one of these points has a unique number. And it's the same number because of the way I set this up with the attribute interpolate. It's the same number every frame, it doesn't change. If I was doing a scatter on animated geometry, you would see that this number will probably jump around now a little bit. Maybe not as much as, actually, let me turn these off. I wonder if that affects it. It actually might be kind of stable, but I bet somewhere around here it will jump around. It doesn't look too bad actually at the moment, but maybe the relax might change things. Ah, yeah, there we go. With the relax on, seems to change it a little bit in certain sections. Point number is not something that you can rely on for being constant very often, but there are ways of setting it up so that, it is more constant, like this. Basically, what I'm doing in this code is I'm asking a question saying, is any particle moving faster or slower than a particular value? And then if it is, I want to remove that particle, but I don't know what that particle number is. And I don't want to have to worry about what that particle number is. So I put at ptnum, which means that any point that is satisfied by this argument, so any point that is less than 1 in speed and greater than 1.1 in speed, this will return that point number. And by putting that at ptnum in there, it just means that any point, whatever it is, whatever number it is, whether it's 58,060 or 41,527, if they are satisfied by that argument there, then they'll be removed. So that saves me from having to go, well, I want to remove 42,157, whatever. It just means that all the points that are satisfied by that if statement are going to be removed. So I hope that kind of helps a little bit. It's kind of, yeah, it's not super easy stuff to get your head around, but I would just recommend kind of, putting down simple geometry and turning on your point display, having a look at the point numbers, trying things like this, where you put a transform down and you pick a point and go, oh, 0.44 here. Okay, so I'm going to affect 0.44 in my transform, and I'm going to move it up. And actually, it looks like it's moving a different number, which is really weird. I'm not really sure why it's doing that. Oh, you know why? Because it's probably doing primitive 44. Let's choose points. There we go. So, and learning about the correlation between, point numbers and how you can manipulate them. You can also use them in groups. So in an attribute wrangle, if I was to put here 0.44 and just say at p.y equals 1, you can see that it moves the point number 44 up 1, or sets that value, that p.y value to 1. So just, try and experiment with those things and see, if you can make sense of it like that. But this is a common thing when you're doing these if statements, or when you're writing things in Vex, that you will frequently use at pt_num. So let's go back and have a look at what we had here. So I'll just run this point number, this popnet again, make sure I didn't mess anything up there. Let's see what we've got so far. So we've got some things, yeah, no worries. So we've got some things being flung off, and at the moment, it kind of feels a little crazy, but maybe not too bad. The other thing that we could do here is maybe just, let's do, I'm just going to duplicate this code. Actually, I'll duplicate this wrangle and test out a few scenarios here. So maybe we could do, if the speed is greater than maybe 0.5, so that these particles that get kept are only there when the things are not moving fast at all. Maybe really slow, so 0.1. I'm just trying to work out kind of what sort of effect this is going to be exactly. And we can use this setup for lots of different effects, depending on how we treat these points and what we do with them. One thing I'm thinking is, perhaps if we just keep the points that aren't moving really, so we could even say greater than 0, so that if they move at all, then they'll just be removed. And what we could use that for is, maybe we don't even need to go into a popnet for this one. Maybe for this one, what we could do is just create a density value. So at density equals 1, volume rasterize attributes. And maybe this one we could run just into a pyro solve for doing some dust, just simple, really simple dust. So let's try, just take the P scale right down and the voxel size as well. Let's look at our resolution. We've got 112,000 voxels. It's not that many, but that's not too bad. Let's put down a simple SOP pyro solver. Set our start frame to 150. And let's go 0.025 and just hit play and see what happens. So we need to go to solving shape turn down the dissipation, turn it right down. So we should just be emitting smoke now, constantly. And you can see it sort of dissipating there. Now, what I want to do here is I've got my velocity from my tornado all the way up here, out tornado vels. So I'm going to bring that, let's have a look at that here, vel.x.y.z. This is a Houdini volume at this point. And you can't, even though it's really crazy and annoying, but even though this pyrosolver outputs, or takes as its input VDBs, it outputs Houdini volumes, and you can't plug a Houdini volume back into this SOP-based pyrosolver. So I need to convert it to a VDB first, before I can use it in another solver. So I'm going to convert it to a VDB, and that gives me, you can see the color change, the kind of greeny aqua color before, and then now they're VDBs. It also says up here volumes and VDBs. They're kind of blue now, but they're 3 components, and we need them to be a single vector VDB component or VDB field. So we're going to do VDB combine, what is it? Convert VDB vector. Can never remember what the name is. VDB vector merge, and that will combine. You can see here .x.y.z, and it's got a little bit of code, but you don't need to worry about that. It just converts it to a single vel field that's a vector 3 signature. So before that, each one of these is a float, and now this is a vector 3. So now with those 2 nodes, now we have one single VDB field that we can use if we bring it in to our new pyrosolver over here. So where am I going to bring that? I think what I'm going to do here is merge it with this source. It's a little bit tricky to do this with these SOP-based pyrosolvers, but one thing that I have kind of learnt to do is to just merge it in like this, and actually just rename the field, because I might want to bring in V here or velocity some other way as well. So what I'm going to do here is just rename this velocity field to, let's just call it tornado vel. And you can see now I've got a field called tornado vel. Now Pyro doesn't know what tornado vel is, but in my sourcing tab here, what I can do is add another field vector, call it tornado vel, and then just add it to the velocity field of Pyro. So you can kind of have whatever field you like, named whatever you like, and then just make sure that you target it to the appropriate field in Pyro, and that, you know, that will work. And you can see now it's doing some crazy calculations, probably because this field is rather large. But let's see now if we can get some motion on this thing. And because that pyrosolver, or the pyro field, that tornado vel field is relatively large, it's probably going to take a bit longer now. So let's just have a look and see. It's taking a while. Let's just step down our voxel size. 0.5, see if that helps speed things up a little bit. Another thing that I do sometimes is just put a time shift down on my source and see, just freeze it to the first frame and see if that could be causing the slowdown. See, it's a little bit faster now. Probably mainly because of the voxel size taking that down. But you can see we've got motion happening. So that would be being caused by the tornado vels that are in there. So you can see that kind of whipping that stuff up. So let's, what are we going to do? Let's take this down a little more. Let's go 0.1. Let's try and get this a little bit faster. So this tornado vel is at 0.075. So 0.05 was probably just a bit too, or 0.025 was probably just a bit too high res. Now you can see it's running nice and quick. So this is an insane amount of dust, but at least the simulation is working, which is cool. You know, we're getting advection via the tornado valves, which is great. But it's pretty intense. So first thing that we can do is on the sourcing tab here, instead of using add, we'll use pull. And we can set the acceleration strength, and I usually just take the cue from the temperature here and put 50 in there. Let's see what that does. A pull is a bit more of a gradual movement or addition of that velocity field to the regular pyro velocity field, so it definitely won't move as much. And if you take down the acceleration strength, it gets up to speed a lot slower, so it's a bit more of a force type effect rather than an addition of velocity being injected all the time. You can see it's moving much less. So you can also take down the scale of this velocity. So we'll go half, and maybe we'll also take down the acceleration, so that we want this stuff to move, but we don't want it to completely kind of, be just too ridiculously crazy. And I can probably turn off my time shift now, which is freezing this to the first frame. So let's turn that off. Let's just see. So all these things start to turn off kind of around here. So we're probably going to get a little bit too much emission, I think. Maybe I do need to kind of go back and rework this a little bit, but let's just see. Let's see what this looks like with that time shift turned off. How's everybody going? I hope everybody's doing some cool things in Houdini. Let me know what you're working on, if you're working on anything cool out there. And I think this will probably be the last day that we work on this tornado, and we can talk later on in the stream about what we're going to work on next. I think somebody had suggested a tidal wave, which I think could be a really cool thing to work on. So yeah, that might be something that we look at next week. So we can see it's definitely not getting pulled up anywhere near as much anymore, but it's an insane amount of dust. I mean, maybe it's not. It's always good to kind of check. And what I'll do here, I'll put down a new volume visualization node, and let's see, put density in here, and then just merge it with my house. So back here. So it's always good to check, with your geometry that you're emitting from, just to see kind of what it looks like. Maybe take the density down and just see how it looks kind of in a really subtle amount. And yeah, it's obviously way too much. So let's try, we've gone through a couple of ideas here. Let's try going back to what we had previously, which was this guy. Let's try that. So this one. Are you working on the bulb explosion? How's it going, Hamid? I think you had a question. You asked me a question I haven't replied to yet. But how is it going? So yeah, let's try this one and see what this looks like, because this one's based on speed less than and greater than. Maybe we can drop our threshold here a little bit so that we get a bit more. I'll make sure that I reply to your question today, Hamid. Sorry about that. I hope it's going okay though. I think I remember what your question was. It was about being fractured. Maybe I can talk about that. It was about the light being fractured, like showing up in the render before it's broken. Is that right? Yeah, that's always. I mean, it's a good thing to talk about because it's a tricky thing to deal with. Um, Sometimes, especially when you've got glass and you want to have it be perfectly transparent before it breaks, but then at the moment of fracture, then you need to turn it on. Usually, what I'll do there is I'll switch, if I can. I mean, there's a few ways to do it, and some are more complicated than others. But probably one thing that I would do there is use a switch to switch between the original model and the broken one at the moment that it explodes, so that you don't see any of the fractures beforehand, because it's very hard to get rid of those fractures otherwise. So that would be my kind of advice. So, and I can show you a little bit later once we've kind of done this stuff what I mean by that. So yeah, this is not working as bad, I guess. Like you can kind of see, we're not getting a big just constant plume of stuff coming off. We're just getting dust emitted when things move. So maybe that's a better option. Let's go a little bit lower. Let's go 7.5. Hardik, you're working on destruction. Cool, that's good. Beginner destruction model. Great. Destruction's a lot of fun. I think, make sure you focus on those fundamental ideas, like understanding point numbers and stuff like that. Even though jumping in and doing all this stuff and all the stuff that I'm doing as well, it's all kind of fun stuff, but it is also really important to understand those fundamental ideas, like what are point numbers? How do I use them? How can I manipulate them? So think about that stuff while you're learning your destruction as well. Just make sure that you keep kind of trying to learn those really fundamental ideas as well. It's all very tempting to to kind of get into pyro and destruction when you first start in Houdini, and I think there is a danger there of kind of missing some of that really important stuff. It's not very interesting. It's a little bit boring to kind of learn it because it's not explosions and it's not water and it's not all the kind of fun, cool stuff in Houdini, but you'll get to a point where, you want to do more and you want to manipulate things more, and you can't because you don't understand that kind of fundamental way that Houdini works. So I know you're just beginning to learn this stuff, so that's just a piece of advice to just always make sure that you focus on those simple things as well, not always just the very cool kind of epic things, for which there are lots of great setups for and tutorials out there, but sometimes they don't really explain to you what's going on or how things are working exactly. So just be careful with that and be mindful of it while you're learning these things. I did the same thing, I started with the really cool stuff and the fun stuff in Houdini, but it did kind of it took me a long time to really get my head around how it fundamentally worked, and when I finally did, it made things a lot easier, and I wish I had kind of started with the basics rather than starting with the fun stuff and working backwards. I think it just took me much longer than it should have to get there with it. So, I mean, there's a weird kind of roof shape there in our smoke, but we can always get rid of that. Let's just keep playing this. Well, I think the SideFx website has a bunch of like fundamental starting things that I would look at first. I mean, obviously I've talked to you about our course. I think our introduction course is a really good place to start, but there are also, lots of good resources on the SideFx website for absolute beginners. And I would just start there. You know, they have that learn section, and just just look at that stuff and work through it. Try and understand those real basic ideas. You can do the destruction stuff as well, and just be mindful of those things, while you're learning that. And if there are things that don't make sense, write them down and then try and sort of search out the answer. I think, rather than just going, well, I don't understand that, but I can make a cool destruction, doesn't matter. Just write those things down and then try and search out the answers. Hamid, you're working on a destruction building by a sci-fi beam. Ah, cool. That sounds good. Like a kind of laser beam cutting through a building. That sounds interesting. How's it going, Hamid? What part are you up to? Alright, I mean, we need to put a lot of detail into our dust here, but I think it's kind of, it's not too bad. Let's combine it with our tornado as well, because it will just kind of blend in to the tornado. You can see, it kind of disappears. So really, the main thing that we're focused on here is just the stuff coming off the roof. And it might not be a bad idea to set a boundary on this so that we limit where this stuff goes, because it could easily just get sucked up really high into the tornado, and then we've got this massive simulation where we don't really want it to be so big. So let's have a look. If I put my middle click on that and look at what max size is, 8.4. So I think if I just turn on max size 10 by 10 by 10, I'll set my center to 5, because, actually, is that what I want to do? Yeah, that should work. I'll do close below 0, and that will set a ground plane there. And let's see what that max size does. It should limit this stuff now. I might need to increase the Y a little bit. Which part looks like the Matrix, Audrey? All of it. It's numbers everywhere. This part certainly looks like the Matrix. Just a whole bunch of numbers. This, I just used to avoid this a lot when I started, but it's really important. So I think it's a really good idea to come to terms with the geometry spreadsheet and just try and understand it and learn as much about it as you can, because it is the easiest way to see a lot of information in Houdini. Alright, so what I'm testing now is just the bounding box. Make sure it's clipping properly. So it looks like it's not really advancing beyond that, which is good. It is... Oh, there we go. It is more. I guess, yeah, maybe that's only 5 there. It's dissipating as well, so it's probably not going to get sucked all the way up anyway, but we do just want to limit it. There we go, it's clipping there. So we might need to increase it a little bit, or just increase our dissipation a little bit as well. Might be an easy way to fix that. Alright, let's have a look. Let's go to camera 3, which is our kind of wide camera. The poster behind me is that one. Let me see. Which one is which? that one is Star Wars, the original Star Wars. I'm not a massive Star Wars fan. I guess I do like it, but, you know, not super into Star Wars, but I do like that poster. It's very cool. And the other poster is Led Zeppelin, Stairway to Heaven poster. Good band. One of my favorites. And then I turned on my, I don't know which way to point. There we go. I turned on my arcade cabinet today. So I got Rampage playing in the background. That's what everybody's watching, isn't it? Not watching me, just watching Rampage. So, yeah, let's do a little... I might change the color so it's a little bit easier to see what's going on. Density... Get rid of that. Make it a bit of a dusty kind of color. Looks like I do need something in there. Temperature, density, I guess. I'll have to... What can I do? No ramp. No. There we go. Well, it's giving me a bit of a weird display because of the lighting, I think, but oh well, that'll be alright. Let's see. This is the thing when you merge volumes in a single object like this, that it only takes the first object in the merge. It takes the first object's visualization, so you can't have two merged together. You'll see if I swap these around, the tornado goes and takes the visualization from the dust. So the way that I would do this is to like jump out, create an object merge in another geometry, so say like out house dust, or do this dust simulation in a completely different object. That would probably be the best way to do it. So if I merge those things together, then have another geometry. Thanks, Hardik. Try and make my room interesting. So yeah, I'll just create like a house dust object here, and then object merge it in, and go to my... I probably should have named that something a little easier to find. It's called grid 1, house dust, there it is. So there's my visualization, and now I can see that separate. You can see that color differently, so it's a lot easier to see now. Well, let's just set our camera kind of here, and maybe just do a little flipbook of that and see what... Just put a random number in there, that'll pop up a new mplay window. And I might start it at frame 150, or maybe, yeah, frame 150, why not? And let's do a little flipbook and see what it looks like. Because until you see it playing back in real time, because the viewport is not, you know, it's not real time, especially when you're dealing with heavy volumes, you don't really get a sense of what the motion is doing. So you always should flipbook your effects, no matter what it is, just to see what it's kind of looking like when you play it back, because it's kind of hard to tell when you're just working away in 3D, and it might look fine at that kind of slower playback speed, but then it might look really crazy fast when you actually play it back in real time. So it's always a really good idea. It's kind of hard to see, but you can make out the different colors, make it a little bit easier. It's pretty slow actually. I mean, maybe I did go a little bit too low on the values of that vel field that I was bringing into this pyro. So maybe I can speed that up a little bit. This kind of really slow motion moving up here of this dust is a little bit weird. Now I don't have any shaping settings either, so this stuff is all very blobby at the moment, so adding disturbance and other kind of shaping settings might help as well. Just break it up a little bit. But I really want to let this run a little more, because it's not until sort of 300 that stuff really starts to happen. We can see some stuff happening now, some, you know, big puffs of stuff breaking off. And, you know, this stuff looks a little bit kind of over the top and thick at the moment, but things like dust and some of these effects, they could just be really, really light, subtle effects that just add a little bit to your simulation. They don't have to be super thick and in your face. They can just be a really subtle thing that just adds a little bit of density and atmosphere to the air. But you know, it's not something that has really solid shadows, and it's not so in your face. And then, you know, some of the behavior might not matter as well. So we'll let it keep going until the house sort of starts to disintegrate. We can really see what this simulation's doing. And I like to just play it back like this over and over again while it's flipbooking. I can just watch it, you know, on loop, and just look for little errors, look for different problems or things that look good. Could I do this Tornado project on my laptop or need a render in low quality because of RAM? Yeah, look, I did lots of stuff on a laptop for years. Because, yeah, that's all I had. I didn't really have a workstation at home. I had one at work. I didn't really need one at home. I had my laptop, but I used to do all sorts of little projects on it. And it was fine. I had 16 gig of RAM. I was limited by the things that I could do. You know, I couldn't do super high res stuff, but this is not particularly high res. So I think you could do it. It'd be slow. You know, certain things, the pyro would probably be slow. But you could certainly do it. And you just, yeah, you need to work within the limitations of what computer you have. So if it's crashing because it's too high res, then you need to drop the resolution and just deal with that. You obviously, yeah, won't be able to get the same quality, you know, that maybe I can handle on this computer with 128 gig of RAM, but that's okay. You know, you just work within the means that you have. I'll show you a little tip when you're doing simulations once this is finished, for how to get more out of a computer that has less RAM. I'll show you a little trick that you can do. So we can see now, as it progresses, a lot more dust is coming off the house. How to render in low quality. So, you know, I think when people are talking about rendering and simulation, just need to be clear about what you mean. I assume you mean rendering when you say render, but yeah, some people mean simulation, and so I'm not sure what you're referring, because we haven't really looked at rendering yet. But rendering, you know, can be fast. You just need to take all the settings down, and I can show you that too. We'll have a look at some rendering options for this. I think rendering is where people struggle most of all to get stuff done in a timely manner, and on a machine that maybe isn't as fast. The best thing you can do is just take the settings down. You know, you get a less quality looking thing, but you get it back a lot faster, and then you can make changes and, you know, just assess what you've got. And I always render everything at low quality and small size until I'm like 100% sure that I'm not going to want to make any changes. And then I'll render the full res thing over a few days if I have to. But yeah, I think a lot of people, when they're starting out, don't really understand render settings, and they waste a lot of time rendering stuff. And they could just change like a few settings and they'd get it back in a couple of hours instead of 48 hours, or, you know, hear of all sorts of really long render times. Some things do take a long time to render, but they don't necessarily have to. And certainly when you're testing stuff, you don't want really long render times, because you want to keep working, keep changing, and iterating on things. There's a lot of dust coming out now that this thing is tearing apart. But you can see the dust is kind of getting swirled up and sucked around the tornado, which is cool. And finally, when we add a little bit of disturbance to this, hopefully it'll look a bit more dusty and a bit less smoky. Alright, so I've seen enough. Let's have a look. Yeah, it's kind of looking cool. I mean, it's a little bit too much. It's a bit too intense, dust-wise. You know, it's a bit crazy, but I think it's a good start. Let's see, these blobs and things are a little bit weird. I guess it's probably down to resolution maybe, and also scale. Like these here. If we have a look at the source, it's not too bad. I guess it's just streaming off because this thing is alive for a long time. 10 out of 10 would get swooped. What does that mean, Audrey? Am I missing something? There's a boundary there, so we probably do need to increase our max bounds. But let's add some shaping. So these pyrosolvers have the nice ability to turn on speed field, and we can then add disturbance based on the control field speed. So we'll do control range 0 to 5 maybe. So this is based on speed. So basically what it's going to do is apply disturbance when the speed is at 5. It's going to do the maximum amount of disturbance, which in this case is 0.5 at the moment. And then as it goes down from 5 all the way to 0, that disturbance value is going to decrease. So it's going to add most of the disturbance when it's 5, and then it'll lessen over time, or over the speed. So I'm going to crank this up. Let's go 10. And let's see what happens. We've got a block size here of 0.2, which is actually probably a little large because our voxel size is 0.075. So 0.2 is probably way too big. So I'm going to go 0. Let's go 0.1, maybe 0.09. And hit play. See what we get. So it's probably moving quite slow at the moment. The other thing that we could do here is rasterize V as well. On these points, we probably do have some velocities. So if I turn on my marker here, you can see they do have velocities. So that will, you know, sort of push the smoke a little bit if we actually rasterize it. So let's rasterize V as well. Then we get a velocity volume on our particles, and that already is set up in the pyrosolver to bring that in on the source tab. There it is there, V into vel. So that will change the result as well. And I'm just going to disconnect my tornado for a second and see how this runs without the tornado. Hopefully I can see. So you can see a little bit of motion there now with those particles, or with that velocity field in there. I just want to see if I can visualize this disturbance a little faster. You can see it plays back a whole lot faster when that tornado field is not in there. So I'm just trying to get a bit of faster playback happening. Let's see. Might go change my setting on my shape tab. Let's go disturbance 50. And I'll go from 0 to 3. And, you know, I can kind of take a clue from this because I'm clipping out my velocities that are greater than 1.1. Probably my speeds aren't that great, so maybe I'll go to 0 to 2. Let's see what happens with that. Ooh, lots of disturbance. So I'm seeing something, which is good. It's always the goal is to see that it's working. Sometimes you can't really be sure if you have really low values and it's really subtle. It's a little bit hard to tell. So now that I can see that that's working, I might just take that up a little bit. And let's make the disturbance 20. And yeah, my block size probably can come down. Let's go 0.5. Now we play the waiting game. There's a lot of waiting in effects. There's a lot of sitting around watching simulations and waiting for results, which can be Can be a little bit painful sometimes. Usually what we'll do when we're working in a studio is, you know, we'll hit simulate and then just work on another shot. So you'll have a whole bunch of shots assigned to you to work on, and you can just move between them, hopefully. If you're waiting for something, then you can work on something else. It's a little bit hard working on your own machine. Because what you would do at a studio is send it off to a render farm. The render farm would simulate it. You wait for it, you get it back and check it. You can check it while it's simulating as well, which is handy. But it frees up your machine so you can keep working. This is a bit of an issue working at home. If you hit simulate, your whole computer just goes, and you know, you can't really do anything else because it's taking all of your CPU and a lot of your RAM. So there we go, very fluffy, but that's what we want from the disturbance. We want it to really kind of make this feel a bit more dusty and less smoky. So let's turn on our tornado again and hit play. Be a bit slower, but we need to test our kind of speed field. Yeah, that's right, 2 PCs. I've got 2 workstations here. I haven't actually had the other one on for a long time, but yeah, it does help to have 2 PCs at home for sure. To have one as a simulating machine, or one to just throw some renders at so you can keep working and don't completely lock up your machine. Definitely helps. Even if it's like, you know, you get a new computer, but you keep your old one just around. Even though it might be slow, it's still good just to chuck stuff on a slow PC and let it chip away at it if you're not in a hurry for things. Alright, so that's looking a little better. What I want to try now as well is we've got this whole setup, which is great, but let's try the debris source out and see if that gives any better kind of look to this. So I'm going to reset, hit play. The debris source is a solver, so it has to calculate and solve, and it stores the result in memory. So it's a good idea to write the debris source result to disk, because it will, you can see it filling up the cache bar here, it will, you know, hold a certain amount of data in memory. So if you don't have a powerful machine, then, you know, it's a good idea to write stuff to disk so that you have more stuff on disk and less being held in memory. It allows you to do more. So let's see what this looks like. So what we can do with the debris source here is, actually the lifespan's pretty long. I'm going to change that to 0.25. Now I'm just going to run that through this. Actually not that one, just this one. This is where we're setting density. Run that into my volume rasterize, and you should see that we get volume rasterize points there. We might need to increase the particle scale a little bit for these because we've got less points. Let's reset. We might just need to up the amount of points that we have on the debris source as well. What I might do is just run this without the tornado again. It's always good to set up your simulation in a way that you can easily disconnect very slow things so that you can test without that. You can see how fast it runs without the tornado. So, you know, it's certainly a good idea to remove those really slow things if you can test certain other things without that main velocity field in there. It's a really good way just to get the look right, make sure the source is working okay, and then finally plug the big beast of a driving velocity field in if you need to. This just gives me an idea of what's happening later on as well. Don't have to wait quite as long. And I could run this simulation just without the tornado as well. You know, might kind of work okay. So we've got that happening. Yes, SSD definitely affects Houdini performance, Hamid. the read and write speeds on your hard drive can dramatically affect how fast a simulation is going to run, or even a render, because if you've got a really slow hard drive, it's extra time on your render. You know, SSD, let's say, takes 1 second to read this, but a hard drive, like an old SATA hard drive, takes 10-15 seconds to load. Like, you know, let's just say that it's that slow, then that's an extra 10-15 seconds on your render. So it definitely does affect it. And this is the first workstation that I've had SSD in, and it has made such a big difference. And they're not terribly expensive now. I ran out of space, so I bought another one. And yeah, they're definitely coming down in price. So I would recommend it. It makes everything faster. Even the internet is faster with an SSD. If you have Chrome installed or whatever on that SSD, it just it runs so much faster. It's just a lot better. Makes your computer feel a lot more usable. So yeah, you can kind of see, you know, this is running. It definitely probably does need the tornado in it just to make it feel connected. But let's have a look at that. So we'll go and run that with the tornado vels. It is painfully slow, unfortunately, but we'll just have to suck it up and wait for it. Yeah, so, you know, I'm keeping this relatively low resolution as well, because if I flick it over to being super high res, then we'll be here all stream waiting for this thing to calculate. So I'll probably do some high res simulations this week, and maybe next week we can just have a quick look at how it turned out. So you can see getting a lot of upward force from the tornado velocities. But I'm kind of thinking that, you know, this is only going to be really, really subtle. The display is kind of a bit weird because I don't know why. I think it's just the color, maybe. Get rid of that. You can see it's a bit different. You can play around with the minimum and maximum as well. Disturbance is a little bit kind of lacking. A little bit smooth. Might just be a resolution thing, but it might also be my speed values. Another thing that you can try and use instead of the speed field is the pressure field. And I might do that in a separate inside, if you go inside the PyroSolver and use a gas disturb node. It's the same kind of deal as the one inside, but it's got the controls look a bit different. Turn off threshold range, go to control, and put in the pressure field. The range is usually really low, like 0.01, something like that. Let's put the mode to block based, and we'll set the block size to 0.05. Now let's have a look at that. Export. What I usually do to try and figure out how this pressure field works is put pressure, export the pressure field, like that. And then on the volume visualization, put pressure in the diffuse field and set the ramp to infrared. And what that will give me is the pressure field mapped to density. So I'll take that down. I did 0.01. Let's see how it looks. And what the pressure field should give you is a field that's kind of like the inverse of the simulation. The pressure field exists like right at the head of the smoke. So kind of as the smoke is pushing through the air, pressure is created right at the top. So all the mushroom cloud kind of heads that you get on your simulation, you'll find the pressure is strongest there. You can see it starting to come through now, and it jumps around and changes a little bit. Probably having that disturbance in there doesn't help. So usually what I'll do is turn off all shaping settings and get a kind of baseline of what's going on, because any force that's in there is going to affect the disturbance, or the the pressure. So you want to get a kind of baseline. So let's have a look and see kind of what it's looking like. And you can see it flashing, and probably what's happening there is the tornado veils are swooping through and then leaving again. And so as that tornado velocity comes through, it injects a lot of pressure because it's putting this big velocity onto the stream of dust or smoke. So it's injecting that velocity and adding that kind of pressure to it. So it might be a little hard to control the pressure because of that fact, because it's jumping around a little bit. But you can also kind of try and adjust the range as well, so that you can see when I take this right down, I get this very sort of hard edge red. But if I take this value up, you can see then maybe, I don't always get red then. I get red sort of in certain areas. Yeah, it's a little bit kind of flashy, which is not great. You can also clip out some of the lower pressure stuff so that you could just get, really high pressure. And it's not working super well. Sometimes it doesn't work as well, especially when you're injecting velocity fields in like that tornado one. Let's turn it back on and see if it adds anything nice. Okay, let's see. So when those things flash kind of red is when we should see disturbance happen as well. I can kind of see it just barely there. I can kind of see a lot more breakup happening on that area that flashed red. You can start to see that breakup happening there. It's a little bit hard to see because of the colors and the black, but I can definitely see that getting fuzzier. And these other areas which are remaining purple are not. So it's only happening on those areas that are really, really going red. And then we can just turn off we can set it back to grayscale or something. Get rid of that. And just remove our range. We can leave pressure in there. If we're just setting it to white, it doesn't really matter. But you can see that, how it gets fuzzier there on those, as that stuff gets kind of more of that pressure field. Now let's turn our other one back on as well. We'll leave that on. And let's see what that looks like. I would probably cache my tornado vels that I'm bringing into this simulation maybe to disk again. I don't know. Something, it's a bit slow for me. I mean, it's not too bad. This whole thing probably would be done in, maybe 20 minutes at this resolution. But it might not be a bad idea to cache it to disk again just before it goes into this pyro simulation. It will help with RAM if you're limited with RAM. But it might also help just make it a lot faster. You can see, certainly without the tornado vels, it's really quick. So they're definitely the slow part of this simulation. So you can see, we got a lot of little edge breakup and little extra details, which is kind of cool. Let's have a look with that combined. It's rising up a lot, which I don't know if I like. I guess combined with the tornado, it kind of is okay. And Flipbook will run a lot faster. Yeah, that's right, Hamid. Every slow step, if you can, cache out anything that is potentially slow, is going to make everything run faster. Even renders, flipbooking, anything. If you can cache stuff to disk, but having an SSD also will help with that. If it's cached to disk and you have slow read speeds, then you'll still be hit with that. But yeah, So I'm not going to simulate this any further, but I think that's kind of working okay. I think maybe it would be nice if it didn't rise quite as much. Perhaps I just need to play with my velocities a little more. One thing that you can do, which is kind of interesting, let's say that I liked everything that was going on with this, except I felt that it was rising a bit too much. And I don't have buoyancy in this because I don't have temperature. So, you know, one thing that you could potentially do is put down a volume wrangle, and you've got tornado. I've got tornado vel here. I might do it before I rename it, just so it's easier to type. I've got vel, and what I could do is say at vel dot y times equals, let's just do 0 for starters and see if that works. So what I'm doing there is basically setting the velocity in y to 0. So I won't get any up and down motion from my velocity field. I will only get x and z. Let's see if it works. We should see this stuff stop rising. Hey, Hardik, no, I didn't watch the Luca trailer, sorry. I'll have to, I completely forgot about that. I'll have to make a note to watch it and check it out. Where's my notes? I'll watch it, and I'll try and remember to. You ask me about it next time. Well, you can already see what's happening. It's no longer lifting stuff right up. So, you know, 0 is basically just completely killed it. So, if we think about it, maybe we just do 0.25. So it's doing a quarter of that motion. So once you get into your setup and you've kind of done everything and you're happy with it, but someone says, well, I like it, but it's rising up too much, you can go, okay, well, I'll just take down the velocity in y, and then it's still going to do the swirling at the same speed, but the upward stuff is going to be a lot less. Yeah, I make notes. I can't remember everything. I make lots of notes, especially things that people tell me, because my mind is full of Houdini nonsense that I very quickly forget what people have asked me or told me, or what I promised as well, what I promised to show people, or files I promised to give people. I always forget. So it's really good. Like when I first started learning Houdini, I always took notes. So I definitely recommend making notes when you're learning, writing down things like what at PT num is. Practice is how you remember all the Houdini stuff. Yeah, but you know, when I was learning, I would make notes of these things and make notes of little expressions, and like that if statement I was doing, I would probably have that written down, you know, on a Google Doc or something that I can take with me, and I can reference that stuff. So yeah, I think, you know, it's really good to take notes and just have something to reference when you forget. There's a lot to remember with Houdini, so I don't know if I would say my love is Houdini. I mean, I do really enjoy working in Houdini, and it is something that I do probably more than anything else. But yeah, I don't know. I mean, maybe I do really love working in 3D. It is really satisfying. I'm less in love with it than I was when I started, but I still really enjoy it, and being able to create anything is really amazing. It's really satisfying to just have an idea and and then go and realize it. And it can be a frustrating thing as well when things don't work out and when you can't, you know, realize that idea that you have in your head. And that comes with experience as well. I mean, you know, the more you learn and the more you kind of figure out what to do in Houdini, the more you can kind of just go, yeah, I'll have this cool idea to do some cool effect, and you can just go and do it. And, you know, that comes from working in the film industry as well. You know, you never know what you're going to be asked to do. So you do just kind of develop this ability to be able to pump out, you know, whatever is required. Yeah, look, I think, you know, I wouldn't say like Houdini is the thing that I love necessarily. Houdini is the tool that enables me to do these things, but prior to this I was using another tool, you know, 3D Studio Max, that enabled me to do similar things. Although, you know, I've talked about it in the past that there were limitations with that, and after a while I started to really not like 3D because of those limitations. So Houdini does kind of free me up to be able to do, you know, the things that I want to do without those limitations, and that is something that I really enjoy. But yeah, you know, it's a tool that does the job, and it does it really well. So yeah, but I think, you know, it took me a while to really enjoy working in Houdini, and that's just a practice thing and a knowledge thing. You know, if you don't really understand what you're doing and you're struggling to do everything, then it is not particularly enjoyable. But I think I just enjoy the challenge of creating things and the process, I think, of solving these problems in Houdini and solving these visual effects problems. I think that's something that I really enjoy. I hate this viewport. The viewport doesn't always do this, but it's probably, yeah, lights don't help. It does this kind of weird gamma thing. So you can see that it has really lessened the amount of vertical stuff that we're getting. It looks a little bit weird now, I guess, but yeah, we can play with that value and try and, you know, just try and make it better. I'm gonna spend some time, you know, simulating this out. That's right. My love for multiple camera angles. Camera 1, camera 2. Let's go inside. Oh, let's see what the dust is doing. I didn't do this. I guess it's not doing much inside at the start. Yeah, so I don't know, I'm going to spend some time simulating this out during the week, and we can have a look at it next week. This is going to take forever. But let's just have a quick look at, so one thing I should mention is what I was talking about. Yeah, maybe hammered, maybe it is black background that's doesn't help with that color thing. So one thing I was going to tell you about with working on a laptop or a machine that doesn't have a lot of power is, let's say I was trying to do this simulation at a really high resolution, but every time I do, it gets to a point, fills up the RAM and just crashes. One thing that you can do is turn off cache simulation, and you have this on .nets. So .network, cache, turn off cache simulation. Because what this does, by default, it's filling up 5 gig of memory. And, you know, you can increase that if you want, or decrease it. But it's going to fill up your memory. And if you only have a certain amount of memory, maybe you only have 8 gig, then it's going to take all of your memory, basically. And if you go over that 8 gig, Houdini crashes. What you can do is turn it off, whether it's there or whether it's on one of these nodes, and then cache your simulation to disk. And what it'll do, so hit save to disk, what it will do is it will just store the single frame that it's on in memory. And then when it moves on to the next frame, it will throw away the memory of the frame before and do the next frame. But it's writing it to disk, so you have that previous frame written to disk. And that allows you to do much more in terms of detail of your simulation and quality than what you could do, potentially, if that was turned on. So that's how I did a lot of stuff on my laptop, is just turn that off, crank the resolution up, and write it to disk. It's a little bit annoying to have that turned off if you're previewing stuff in the viewport. So sometimes you do need it on when you're playing, but when I go to file cache, I will turn it off so that it doesn't fill up my memory. And you can see what happens when I have it off now. If I hit play, it will still simulate, but you can see the blue bar is not filling up. So if I stop this simulation and try to go back to frame 157, it resimulates it again because it's not storing anything in memory. So you want to turn it on when you're working in the viewport, but when you want to run it to disk, turn it off. And this is only really a problem if you're running out of memory, but that has enabled me to do much greater things on a, you know, even a Microsoft Surface I use Houdini on. So, you know, it's no, you're going to run into limitations, but there are things that you can do to kind of optimize. And now let's have a look at rendering this tornado. I think we did, I can't remember if we had a look at it at some point, but let's go to the last frame here. Maybe a little bit less. Yeah, let's go there. Let's see, did I create a mantra node for this? I do have a mantra node, so maybe I did do some rendering at one of the first streams of this project. Let's just hide that. And I'm going to, so I've got out tornado volume here. I'll plug that into where my transform is. And then what I'm going to do is the same thing that I did here. In fact, I can just duplicate this one. Object merge. And this is another thing. I'm getting stuff cooking out, which means that something's simulating somewhere. It's probably the house. But I'm going to turn off the little brain icon down here, disable simulations, and that will stop any .NET from cooking out. So I'm going to bring in out tornado volume. There it is. And let's see, did we put a material on this? Yes, we did. So I did have one. I'm going to call this render tornado. Oh, did I do the wrong one? Yes, I did. Whoopsie. Copy. There we go. Hide that one. Render tornado. Grab that material. Put it on there. And then we'll make this one the house. So this one can be the house that we render, which is here. And, whoa, no, fatal error. Okay. Let me just open Houdini again. It's bound to happen eventually. Luckily, Houdini's crash files, because I haven't saved this in a while. Luckily, Houdini's crash files are pretty good. So I'm just going to open that. Okay. Temp. Tornado Elephant Bonanza 12. What a file name. Okay, and now I need to save this back into the original location. So let me find where that was. No, it's all good. Nothing lost. Just open the temporary file. Yeah, so when you crash and you get that pop-up, the file gets put in this $temp directory. So when you go to file open in a new Houdini, you can see it there. And they're usually pretty reliable, unless it's a pretty bad crash. The file will be fine to I just opened it, resaved it back into the original directory where it came from. And as you can see, we're back up and running. So what was I doing? I got my simple dust. I'm going to put down a principled shader, and this can be my house shader. I'm going to turn off reflection, give it a little woody tone. What are we going for? There we go, something like that, maybe. So let's apply that to the house. /map/ house. There we go. Let's look at camera 3. What do we got? 240. Yeah, let's try this one for starters. So we've already got our key and fill light in there. I do remember talking about this now. Let's go render view. Camera 3. Turn off progressive. Hit render. And I've already set up a few things on here from last time. So let's just have a look how fast this renders. We're rendering 1280 by 720. It's not a resolution that I really like. Let's go 1920 by 1080. So just do HD TV. You can see it's pretty fast, although, you know, my machine is arguably faster than your laptop hard disk. So let's look at how, you know, I can speed this up even further. Now, I think I talked about not using environment lights, and that is something that is going to make this incredibly slow. If I put an environment light in here with, you know, a HDRI, it's going to slow it down a lot. The lighting, you know, looks cool, looks kind of nice and realistic, but it's super duper slow. So I avoid environment lights as much as I can with volumes, certainly. And you can see here I've got, at the first stream, I set up this key and fill light. So I've got a key coming from behind, which is this. If I up the exposure. Well, it doesn't really seem to have done anything. Turn it off. Oh, there we go. Why didn't that do anything? Oh, there we go. It's a little bit brighter now. And I've got this fill light, which is filling in the backside. One thing that happens with this interactive viewer, you can see I'm turning things on and off and nothing's really changing. If I make this like pink. Oh, there we go. We can see it's really subtle, this one, actually. Maybe that's why. So the fill light is very subtle. So it is a good idea sometimes to give it just a crazy color, just so that you can see it. See what it's doing. Key light, yeah, make it green. Yeah, look, even 16 gig would be better than 8 gig. 8 gig, you certainly will struggle with a lot of things. Look at that crazy 80s green and pink tornado. But you can see it does give me a good indication of where my lights are contributing. So I've got my green key light hitting this backside of the tornado, and then this pink fill coming in here. And the pink fill is pretty kind of subtle, and you can see, you know, before it wasn't really clear to me which was doing what, whether the key should be illuminating that or the fill. But now with them being so contrasty colors, I can really see where those different areas are contributing to. So, you know, if I want to up my fill light, then I can really see that a lot clearer. Acid tornado, that's right. And you can see now a little bit of pink creeping into this area here. So it is a good kind of way, a diagnostic tool that I use to color my lights so that I can see where they're contributing to. I think I also talked about adding, oh no, I did not. Adding, I'm sure I have in the past, adding an AOV or an extra image plane for direct lighting, or you can do combined lighting. I usually do combined lighting per light. And this is a great diagnostic tool for seeing the contribution of each light by itself. So up here now, under our, so I turn on the view bar. Under the view bar, now you can see I've got key all and fill all. And if I choose key all, I can see just the key light contribution. And if I choose fill, I can see just the fill light contribution. So it makes it really helpful when I want to see, again, what part is being illuminated by the key or what part is being illuminated by the fill. So I find that really handy. Now, and then, you know, finally, I'll just eventually set those back to whatever color I had them initially. I find that it is a good idea to not necessarily have white for all your lights, because it does contribute to it looking very sterile and 3D. So it is a good idea to kind of, you know, give them a bit of warmth or a bit of color just to make them feel a bit more interesting. You don't want it to be too crazy saturated, but let's see. All right, so this is pretty slow, and this is, you know, this is too slow for me working. So what I would be doing is coming to my mantra node. First thing that I always do is override camera resolution and render half res. And you can see that renders faster than twice as fast, but it renders a lot faster. So that is the first thing that I will do. And it looks basically the same. Sometimes you can't see really fine details with half res, but in a studio context, we never render full res until we've got it signed off or it's approved. We always work at half resolution. So there's no reason why, you know, anyone else should think that they have to render at full res just to see things. Sometimes you do, like if the things are really fine detail, but there's absolutely no reason to render at full res until you're like ultimately very happy with what you have, and then you can flick it over. But I always work at half res until I'm done, and basically I just want to up the quality a little bit. So let's go drop the pixel samples as well, and you can see I get a very noisy render, but I get a render back in 3 seconds, and that's great. For diagnostic stuff, for testing lights, you know, this light I want to change. I don't really like that kind of red color that I've got there. Now I get my result back almost instantly. And if you're looking at working on a laptop or some low-powered machine, then, you know, it might not be 3 seconds for you, it might be 10 seconds, but 10 seconds compared to a minute is going to allow you to make changes and make all these different kind of lighting scenarios that you could run and just see what works and what doesn't. But if you're waiting a minute for every frame, you know, you can't just do this. Turning on GI for the volumes, absolutely, that isn't something I would only do if it was really, really, really necessary, because that is going to slow down this render like crazy. So yeah, I avoid it. Same as why I avoid doing environment lights. Look, it adds a certain something, but the thing that it adds is very kind of minimal. So I would argue that, you know, it's not really worth it a lot of the time. You can see that it gives this overall kind of lift. Shadows kind of aren't as dark, and it gives this kind of effect of scattering. But, you know, that is something that I can also fake, and I would, because I just can't have super long render times. So yeah, it's not something that I would use. I tend to turn off as many of the things that are going to slow down my render. You can see like the difference is pretty small with GI turned on. I mean, you know, some renders you'll see it more noticeably than others. Clouds, things where you do actually want scattering, you know, it might be a more noticeable sort of difference. But you can see the difference here is fairly small, and I could potentially adjust my lighting or tweak this in Nuke by lifting some values, maybe gammaing up, and I'd get basically the same result. So I don't think it's worth it for a lot of scenarios. Some scenarios, yeah, maybe. GI, environment lights, anything that is going to use scattering or introduce a lot of light samples adds noise. And when you add noise, the only thing you can do is really up your pixel samples or your stochastic samples when you're dealing with volumes. And you just have to keep upping them until the noise goes away. So that's why I try and avoid it, because you can potentially end up with incredibly slow render times. And that's just, yeah, it's not tolerable. You want to be able to iterate over things quickly. And, you know, that volume, volume bounces, GI, is like an icing on the cake sort of thing. It's not really going to make a difference, a massive difference to the overall look. It's just might make a little quality boost. So it's probably not something that I'm ever going to turn on when I'm testing lighting. It might just be something that when I'm happy with my shot, everything looks great, let's give it a bit of volume bounce and see how it looks. But like I said, it's something that I can kind of fake pretty well, so I don't really do it. And there are lots of ways to kind of fake it, you know, shadow intensity, turning the shadow density down, upping the shadow color from black to something else. On the material, I think I may have already done it on here. Shadow density scale. So by default, that's set to 1, and you can see that the shadows are really, really dark when you have it at 1. It makes for a nice contrasty kind of render. But if you want to get that kind of feeling of scattering, then you can take the shadow density down, and it gives you that feeling of global illumination because the shadows have been lessened. So you can see the lower I go with that, the more the light is kind of penetrating inside because that shadow is much less dark. So yeah, that's my take on GI. GI in general, I just avoid like plague because of the noise that it introduces. And with Mantra, you know, Mantra is slow, so you want to try and limit the amount of things that you do that are gonna slow your Mantra render down. All right, let's take a snapshot here, and what am I gonna do? I'll go to 360. Now the house is kind of getting lost in here. I mean, it's correct. It's getting shadowed by the tornado, but it is kind of getting lost. So quite often one thing that I'll do, I mean, in reality, I would be rendering this probably separately so that I have that as a separate thing that I can tweak in comp. And just to show you probably what I would do there. Yeah, I've used Maya a little bit, but not really. It's not something that I've had a great deal of experience with. I sort of went from 3D Studio Max to Houdini. I've used Maya a little bit, but not massively. So what I would be doing in reality with this stuff is rendering the house by itself, like this. So if we have a look at this, let's choose house, hit render, flick that back to half res. There we go, nice and fast. And that gives me the ability just to sort of simulate what I would be doing with that. You know, maybe in comp, I want to just brighten that up a little bit, and I can. But if I try to do that here, you know, I can't easily separate the house and the tornado. Now, what I need to do, though, is add in my tornado in here so that it correctly shadows this, as well as mats out things that are behind the tornado. So I put enforce matte, render tornado. And then you'll see, let me take a snapshot of it before. You'll see those things receive shadows now, and it integrates better. But now what I can also do is add in specific lights for specific things. So I might just duplicate this, or actually I'll just rename this one to be tornado. And just pull in the tornado here. Get rid of the star out of candidate objects. Candidate lights. So here I can pick fill and key. I'll put those in. And actually I'll do force lights. So candidate uses the view flags. But force is just going to have them be on, whether they're hidden or not. And what am I going to do? For the house, I'm actually going to add an environment light. The forbidden environment light. But environment lights suck for volumes. They're really, really slow because of all the samples they throw out. But for hard surface geometry, they're not too bad. They do introduce noise, but it's going to work a lot better for illuminating this. And what I can do here is, just in the house, still got the star in there, but if I go force lights, I can have all these lights on for the house, but on the tornado, I'm not doing that. So that's the other good thing about doing separate render passes, is it's very easy to just pull in an extra light just for this one pass, and it won't affect the other pass. The other way to, you know, kind of work on that, if you're rendering them all together and you want to do a similar thing, is to add things or exclude things from the light mask, like that. And then you can render them together with different lights. This is a little bit strong, so I'm just going to turn it down a little bit. 0.5, 0.2. Let's call this env. It's not showing up here, so I feel like that doesn't have that pass. So let's go house, images, extra image planes. We'll add it again. So I think I just created a new mantra for this one. Combined lighting per light. There we go. So we've got key, we've got fill, and we've got env. So now we've got this kind of environment light, which is basically kind of giving us the GI sort of feeling. We also don't have a ground plane in here, so I'm going to put a grid down, make it really large, 100 by 100. And I'm just going to call this ground. And I'm going to bring that into my render as a matte object. Might not see much of a difference there with having it on or off. Let me just make sure that it's actually big enough. Yeah, it looks big enough. What this will do, because environment lights, and you can see it here, the environment light is 360 degrees, and it will have some light coming up from underneath. And that doesn't look very realistic, you know, when you've got a building, say, that doesn't have a floor. We'll actually be getting some illumination coming from below. And that's not what you want. So you put a ground plane in, either put it in the matte slot or the phantom slot, and it will stop light from bouncing or from being shot by the HDRI up from the ground. So that can really help. It can help something sit on the ground better if it's not. And we'd probably do the same thing with the tornado. So we would actually take the grid, which is the, in this case, this is the house, and we would take that ground plane as well and add that in there, like that. And that will give us, hopefully, actually I don't think the ground will have too much impact on the lighting because we're not using the environment light, but it will cut off anything that is actually going below the ground, which is good. You know, when we come to composite this stuff, we don't really want the tornado to be going below the ground plane. And you can see the house hold out there. So without that, we just get the whole tornado rendering like that. But then when we come to composite, it won't sit properly with the house because we have these things in two different layers now. So we need to have the holdout in there. So when we come to composite these things together, so that we get both things in the same layer, then, you know, they'll line up. Nice and fast. 14 seconds, that's pretty good. Let's have a look at our render settings again, just see what we've got. There's other things with volumes that you can take down. Volume quality, you will see very little difference in a volume quality of 1, 0.5, even 0.25. You can see very little change here in my volume. Arguably none, but it does help with the render time. Might help a little bit. Let's see. 14. It's probably still going to be roughly 14 seconds. But it can definitely make a difference in certain scenes. Shadow step rate is something you will see a difference with. If you take that down too much, you can see now that the shadows are looking a bit weird. So you do want to be careful with that. I find 0.5 is probably as far as I would want to go with that. But again, lowering those things can really help with the render times. On this, probably, yeah, there we go. Got it down to 11 seconds. So definitely is worth adjusting, and it looks basically the same. So yeah, I think that's a good thing to try. So we got that, we got the house. Let's take a snapshot. And again, I'm not using diffuse bounces. I never do with Mantra. But turn it on, you will see a slight difference. Let's see. Oh, I turned it on the wrong one. House. Limits. Diffuse. Overall, just a lift. And for this kind of distance from camera, that lift and the noise that introduces, for me, I can just do that in comp. So, yeah. But occasionally, and I think for like really close scenes or with lots of color and lots of different objects bouncing on different surfaces, diffuse limit can work really well. But you know, in a lot of scenarios, I find that stuff is just not worth it. It's worth taking down the limits though. Not that we have reflections and refractions on this object, but that is another thing that I always take down when I'm working on this stuff. And we should probably turn on motion blur because this is moving. We need to turn on motion blur, but we also need to enable sampling, geometry, velocity blur. And that will then blur those objects by the velocity attribute that exists on them. So you can see that there. So you have to make sure that you have your velocity on here. So we've got our unpack. There it is there, V. And we're transferring it on the unpack. But if I don't do that, you'll see that doesn't work again. So you have to always make sure that you have a velocity attribute on there and spell it correctly. There we go. So velocity definitely helps things, velocity blur. Motion blur increases render time. Yeah, it does. It doesn't with Mantra increase it that much. You can see that we've got actually it decreased. It went up. We've got 3 seconds here with it off, and 3 seconds with it on. So it doesn't really make a huge difference. Certain times it can affect it, certainly, but for this scene it would be fine. We do also want to turn it on for our tornado as well, because what we'll get if we don't have it on for the tornado pass, we still have our house in the tornado as a holdout. But if we don't have velocity blur on that, they won't line up. So we need to turn it on for our tornado pass as well. And that then will give us a holdout with motion blur on it. And we could also enable, there you go, you can see that little smeared edge there. So we could also enable it for the tornado as well, although arguably it's not super necessary, but we could enable velocity blur for that. And the first thing to check though would just be that we have a velocity field. Yes, we do, vel.x.y.z. So let's enable that and see how it changes. Take a snapshot. You can see it shifting slightly. But with this particular simulation, I feel like it's probably not super necessary. So, you know, you could either probably have it on or have it off. Doesn't really matter. But it's that which is going to control whether it has it or not. So we can have the house having it on and the tornado having it off, and that's fine. As long as we have it turned on in our render settings, we can use that little drop down on each object to determine which one has it and which one doesn't. And then, yeah, you know, this is going to take, and this is calculate. I always bring up my calculator to work this out. So this is a pretty long simulation. Maybe we only render from 150 to 500. So what's that? That's 350 frames. So 350, they're probably not all going to be 36 seconds long. Some might be longer, some might be shorter, but let's do 36. So we'll do 350 times 36 seconds. So that's 12,600 seconds divided by 60 to get it in minutes. 210 minutes divided by 60 again. 3.5 hours. So it's a reasonable amount of time, but it's not, it's not 24 hours, it's not 10 hours. But then if we look at a house is only 3 seconds, so if we do 3 times 350, it's probably, it's probably like 1,050, I'm guessing. 3,050 divided by 60, divided by 60, 0.3 of an hour. So I don't know, whatever that is, 15 minutes or something. Or not, no, less, more, whatever. It's less than an hour. That's great. So yeah, I always work this stuff out because it's really, if you're looking at 5 minutes a frame, let's say, and you got 350 frames times 5. Good old calculator, that's right. That's, then we just divide that by 61s because we're in minutes now, and you've got 29 hours. That's 29 hours your computer is kind of unavailable, and that's just not cool. So it is always my goal to get this stuff down as low as I can get it, still maintaining the look and the feel that I need and the quality that I need, but I want to see this number come down. I cannot wait 29 hours to see something. So I always get my calculator out, and if it's under a minute, I kind of know that I'm going to get it back in a few hours. But if it starts going into the minutes, then you're like, oh man, this is if I've got 350 frames, this is really going to take a long time. So it's something to be mindful of. Let's go to Karma. Well, yeah, Karma's in beta. I'm not really touching that. Look, I use Redshift. Redshift's a lot better for certain things. Hard surfaces, it does really well, and I can spit stuff out of Redshift a lot faster than I can in Mantra. But it doesn't hook into Houdini as well as Mantra does, obviously, because Mantra is native. It can hook into everything really well. And that's the downside of using like a third-party renderer. Yeah, I've investigated Karma. The other thing with Karma is I feel like it's just such a different way of working that it's a bit of a pain to set up, other than, like, I just wish that they made Mantra better and left that kind of way of working alone. And then I would probably use whatever they updated. But it will force me one day to learn about Karma and try and adjust to that way of working. But yeah, I don't really like it. I don't really like having to go into a completely different context and bring everything in again to render. Whereas I find this just so easy to get going. That, yeah, I don't know. It's that workflow shift, I guess. It's always difficult when something new comes out to shift your way of working over to something else. USD, yeah. I mean that's where the power is, I guess, with that stuff. Is being able to utilize that. For me personally, I don't see a great need to use something like USD because I don't really work on like overly complex scenes with lots of assets and lots of versions. But I mean, certainly at studios use USD. USD, for anyone that doesn't know, is Universal Scene Description, and it's basically just a way of managing assets, updates, people working on different assets and different departments, updating them and making sure that you have the latest thing. And it's really good in a studio context because it makes that stuff quite easy and quite flexible. But working at home, I don't know, for me, I don't really see a massive need for it. But maybe I just haven't found that way of working with it that's useful to me. Yes, it is. I mean, it is. All of this stuff is mostly code, but there are, you know, it's the way that we, as artists, work with it. That there are user interfaces for. But yeah, I mean, it is mostly just like a kind of pipeline. So it is all about code and hooking into different aspects of different softwares or different kind of aspects of Houdini. That is all handled through Python, I imagine. It's not a world that I know a great deal about, and I'm fine with that. You know, I just make my pretty pictures and you know, let somebody else worry about how the pipeline works. But it certainly has made projects work a lot better. I think when I was at Method, we first used it on Jumanji, and it made handling massive scenes just so much easier. And I think, you know, we probably couldn't have done it without using USD to handle that stuff. So yeah, it definitely, you know, Pixar developed it. They've been using it for a long time, so it obviously kind of has come from a really knowledgeable place. But I guess everyone needs to figure out how they can use it and how they can integrate it. Some of these things, though, are not, you know, not necessarily made for working at home. They're more for studio environments, or where you have these complex projects with lots of moving parts. And that's, you know, for the most stuff that I'm working on at home, that's not really what I have. I have a very small amount of moving parts, so I can manage it, and I don't really need a whole pipeline. I just need my notebook and my memory. But yeah, you know, it's good to learn about this stuff, because if you go into a studio environment, then you will experience this stuff, and if you know a little bit about it, then you'll know what people are talking about when they say the USD data or the scene whatever needs to be updated. Then you'll be like, yes, okay, sure. Anyway, I'm out of time. How about making a tsunami? That's right, all the houses getting destroyed. Yes, I think I will do a tsunami. I don't know what kind of scenario it will be yet. I'm not sure. I've got a few assets and things that I might put together, and maybe, you know, we'll try and create a little scene, and we'll do some destruction and some water stuff. I'll probably focus more on the water than the destruction, but you know, if it's starting to look cool and destruction will sort of take it to another level, then we'll look at that, and yeah, we'll do it over a few streams, so should be cool. I'm pretty sick of the tornado, to be honest. You guys probably are too, maybe. I might do some renders this week of this, and some simulations of that extra dust that I did, and we can have a look at that next week. But yeah, I think, you know, a new project would be good, and a tsunami sounds pretty cool, or a giant wave, whatever, you know. Tsunamis don't tend to be really giant waves in reality, do they? But yeah, cool. Well, thanks for joining me, guys. I look forward to seeing you next week, and thank you for your questions. And feel free to recommend project ideas, or, you know, or other things to talk about during the streams. That stuff does help me, and I do write it down. So when I have space for a new project, I'll look at that stuff, and yeah. No, movies like them big. That's right. That's right. They don't look quite as impressive in reality, but still terrifying. Cool. Thanks, guys. I'll talk to you guys next week. Bye.